Very good morning, students. Welcome to IIT NEET Foundation or Focus C program by Krishnaveni Talent Schools and the Mastermind Schools. So once again, I welcome all the class 8 students for today's session. As you all can see on the screen, and you are well aware, my subject is physics. We are in class 8th. Today we are going to start a new chapter, that is chapter number 5, friction. And today we are the session number 1, right? So after completing the 4th chapter, today we are entering into the chapter number 5, friction, which is also a small top chapter which we complete in 2 sessions. But the friction plays very important role in our day-to-day life. We cannot see the friction. We cannot produce the frictional force, but it is a nature's force. Friction is nothing but a force which is occurring in nature. But how can you know, sir, there is a force is there? So there are various examples in our day-to-day life that such kind of force exists in nature. By that only, scientists study about this type of force. So no doubt, friction is a force which always opposes the direction of motion. Which always opposes the direction of motion. Means it will act against the direction of motion. Suppose you are walking front. So it acts against you and make you to walk properly. If the force is not there, you may not walk. You may fall down. Such a wonderful gift that nature given to us is this friction force. Suppose when you roll ball, you take one ball and roll on floor. You apply some force and rolled. After some distance, it will stop. Why it is stopping? Because of friction. If friction force not there, the ball may go up to infinite distance. Such a wonderful force which is protecting us from so many dangers. Of course, there are some negativities also there in friction that we'll discuss about this kind of force in coming 2 or 3 classes, right? So it's a wonderful force, no doubt. It is more useful in a, see here. This is also a friction. A person see how is skidding and stopped. Example, see here. There are 2 bodies, they are sliding down, right? One is coming very fast, one is slow. So where there is a frictional force is more, it will come slowly. Where frictional force is less, it comes speed. Why? Depends on its mass, and the frictional force changes with the various factors, right? So this all comes under the friction. Okay. So when you move to the chapter here, we will discuss in depth about a wonderful nature force. Wonderful. It's a nature's force. We are not producing that force, right? We are not discover that force. Just discover. We are not produce. We are not applying by some other source to produce a frictional force. It is purely a nature's gift. Okay. So that is the chapter number 5. You can see on the screen. So friction. If you slide or try to slide a body over a surface, just now we have seen in the one GIF, the motion resisted by the bonding between the 2 body and surface. When the one body is over the surface, so there are 2 bodies are in contact. This force will comes in play when 2 bodies are in contact, not in air. Okay. This resistance represented by a single force called friction. So it's always a, why you are calling resistance? Because it always acts in the opposite direction to the motion of a body. Okay. Friction is a tangential contact force that opposes the relative motion between two bodies. So see here. Suppose here we place one book here on table. Right? When you apply force like this, the frictional force will come in this direction, opposite direction. It resists the motion. It always resists the motion. Such a wonderful force which resists the motion of a body, which resists the motion of a body is called frictional force. Right? That is when this force will come into play when two bodies are in contact. When two bodies are in contact. Right? When two bodies in contact with each other, this force will come into play from nature and helps us to for so many things. It is helpful in so many ways. Of course, there are few drawbacks are there, but very important force in our day-to-day life. Now we'll come to exactly to the topic. Right? So friction, the force. So friction is nothing but a force only. The force which opposes the relative motion between two bodies in contact is called frictional force. The first point you can note down. Right? First point you can note down there. The force you can note down in notebooks as a important point or synopsis, whatever name you given, no issue. Okay. Okay. Just make it as a point, simple point, very, very important chapter. It's a very big chapter, very big chapter. When you keep going from the 9th class, 10th class, 11th class, 12th class, everywhere there is an extension you can find. Right? From every class after this, we'll come across this wonderful force. Now, each body applies force on the other. As per Newton's third law, for every action, there is equal and opposite reaction. So every body, when your two bodies are in contact, one body exerts force on second body also exerts force on the first body, right? So opposite direction relative motion along the common surface. So the exact opposite forces, just as per the third law. The magnitude of frictional force depends upon the nature of the two surfaces in contact, which are each other. So, second point you can mention, very important. The magnitude means how much the strength of the frictional force. The strength of the frictional force mainly depend upon the nature of two surfaces in contact. Suppose we have smooth table and book. That is two surfaces. Table and book surface are surfaces. Suppose you have water and boat. Water is the one surface, boat. When the two bodies in contact each other, those two bodies are considered as the contact bodies. So depends on the nature, whether the contact bodies are hard or soft, depends on that, this friction. Okay. So cause of the friction. The original friction is due to surface irregularities at molecular scales. Why friction come in play? Because of the surface irregularities. Even though some floor looks very smooth, there are so many irregularities which we cannot see with our naked eyes. We can see in the micro views. So because of that irregularity of surface only, this frictional force will come to act. Even a high polished surface, see, very important. Even a high polished surface has irregularities. When two of those surfaces are placed together, even though it looks very high, smooth, polished, but there are some irregularities in the molecular arrangement. Therefore, some sort interlocking of the or welding of the uneven portions occurs due to interaction between the molecules. Suppose, for example, one surface like this irregularly, even though you cannot see it, like that. When you place another body, they interlock with each other like this, interlock. Right? Because of this interlocking also, the friction will cause come into play. See, you have clearly shown. See, it's looking like very smooth, but see how the interlocks between the two surfaces. Two bodies you kept one over the other to make it as a sphere. But there is interlocking can be there, will be there. We cannot see them with naked eyes. But that interlocking makes the body to fix to each other and frictional force comes into play. Right? So that is a very important reason. So frictional force is a force which always opposes the relative motion. Relative means motion over one body over other. Relative motion. Its magnitude mainly depends on the nature of the surfaces. Very important thing. And this is generally because of the irregularities of molecular arrangement. Okay. Then factors affecting friction. So there are some important factors which influence the friction. Whether the friction increases or decreases, good or bad at that place, that is affected by some factors. Number one, weight of a body. A body having more weight will have more friction force. This is obvious because whenever the weight of the body is more will be the interlocking between surfaces, making it is difficult to move the relative to another. Very big container is there, wooden container. If you want to move it, it is very hard when compared to the very small one. Because high one is there, that interlockings are more with the second surface. Because of which we need to apply more force, that is to overtake the frictional force, we can move that container. So greater the weight, greater the friction. Remember. Next. Second, a very important point. Nature of surface in contact. What are those two surfaces which are in contact? Depends on the nature of the surface. It depends. That is, a body that is placed on relative smooth surface will have less friction. Surface is smooth, friction and is easy to move. Considerably, a body placed on the wooden surface in the first and glass surface in the second. See, wooden, glass. Two surfaces you are taken. One is wooden, one is glass. Glass is the smooth surface, wooden is the rough surface. You place same body on that, same body. It would be comparatively difficult to move the body of first surface situation than the second one. So, when you place the body on glass, you can easily move. But wooden will take some more effort is required. Because when there is a wooden, there is a rough surface, there is frictional force is more. This is because the glass surface is smoother than the wooden surface. Hence, we can conclude that the smooth surface will offer less resistance. Smooth surface will offer less resistance when compared to rough surface or hard surface. Yes? So, second factor is surface. The nature of surface. Whether it is smooth or rough. Right? Smooth surface offers less resistance. Suppose there is a smooth floor is there, rough floor is there. You drop the balls at same speed. We'll see the smooth surface ball will go more distance and stop before rough surface. Rough surface stop earlier only. Because rough surface will offer more resistance, so the ball will stop early when compared to the smooth surface. Clear? So one is the weight of the body. Second one is the nature of the surface. So friction is independent of shape. Very important point. So friction force due to given material for a given weight of the body is same irrespective of the shape of the body. Body may be either spherical or square or rectangle or triangle or any kind of shape of any size, no matter. But the frictional force does not influenced by the shape of the body. Right? It is only depends on the weight of the body. Hence, for a given weight of the body, the same frictional force will be applied for any contact area, both with surface. So, for example, a sphere, when you place on surface, the contact is less. For example, see, here we place the sphere on floor, square on floor, rectangle on floor, triangle on floor, some other section also. Here, the area of contact is less. Here is area of contact is more. Here is still more. But still, if all are same weight, the frictional force is same. It depends purely on the weight only, not on the shape of the body. It doesn't depend on the shape of the body. It depends purely on the weight of the body. Remember, okay? Then, friction. So before going for this, because friction is evil, we are saying here. Why? Because some cases it is a danger. But before going for that particular part, let me show you video on this. Then we'll move to the why friction is evil.
Factors affecting friction. So we will be understanding how these three factors, that is nature of surfaces in contact, normal force, and the surface area of contact, will affect the friction. So let's try to understand this one by one. So let's say I have a box over here and the box is kept over a surface that is pretty rough, that you can see over here as well, right? Now let's try to push this box. So you are able to see, as I'm pushing this box, the ground is applying a frictional force of 94 Newton in this case. Now what would happen if I make the surface smooth? Will the friction force increase or decrease? Now in this case, the surface is very smooth. Now let's see what effect does it has on the frictional force. Now you are able to see the frictional force is only 14 Newton in this case. So we can say that as the roughness of the surface increase, the frictional force also increases. So we can conclude that the rough surfaces create more friction because of more interlocking of surface irregularities. Let's try to understand what do we mean by the interlocking of surface irregularities. Let's say these are the two surfaces, surface number 1 and surface number 2. And let's say the surface number 1 is trying to move over surface number 2. So when it is trying to move, so there would be a relative motion between these two. And because of the relative motion, the force of friction will come into picture. Now the reason the force of friction comes into picture is because of the irregularities between these surfaces. Now if we see from a microscopic level, the surfaces are very irregular, and because of this irregularity, the friction is there. Now as the irregularity increases, that would happen in the case of a rough surface, the friction would ultimately increase. But in the smooth surface, the irregularities would not be that much, and hence the friction would not be that much as compared to that of the rough surfaces. Now let's understand the second factor, that is the normal force. Let's understand how the normal force would affect friction. But first of all, let's understand what do we mean by normal force. Let's imagine that there is a box of mass m lying on this particular surface. Now, there would be a force of gravity that would be pulling this box downwards, and that force is given by m into g. Now, this surface would be applying an equal and opposite force in this case. So, in this case, the force would be equal to mg, and this is what is called the normal reaction. So, the normal reaction is the force exerted by a surface. In this case, this is the surface that is applying this force, that is the normal reaction, and this force is normal, or we can say perpendicular to the object resting on it. So with respect to this surface, the force is at 90 degrees, and that is what is called the normal reaction. Now please note that the normal reaction is coming out to be mg in this particular case. It might not be for all the cases. Now since the weight of this body would be equal to mg, so in this case we can say that the normal reaction is equal to mg. So let's understand what effect does this normal reaction has on the friction. Now, let's say in this case, the mass of the box is 50 kilograms. So the weight would be 50 times the acceleration due to gravity. If we assume the acceleration due to gravity roughly as 10 meter per second square, so we can say that roughly the weight of this body would be 500 newtons. And if the weight is 500 newtons, in this particular case, the normal reaction will also be 500 newtons. Now, let's see what is the frictional force in this situation. So as I'm trying to move this body and the body has started to move, we can see that there is a frictional force of 94 Newton in this case. Now let's increase the mass of this body. So if we increase the mass of this body, now the mass becomes 50 plus 50, that is 100 kilograms. So we can say the weight would be 100 times the acceleration due to gravity, that would become 1000 newtons. So in this case, the normal reaction becomes 1000 newtons. Now let's see if it has any effect on the frictional force. Now as I'm trying to move this, you are able to see that the frictional force is 188 Newton, which is much greater than the previous frictional force. So we can say as the normal reaction increases, the frictional force also increases. Now finally, let's understand how the surface area of contact affects friction. Let's say I have this box and the mass of this box is 5 kilograms. So the weight of this box, considering g as 10 meter per second square, would be equal to, so we can say the weight in this case would be equal to 50 newtons. And as we just saw in the earlier case, we can simply say that the normal reaction in this case would be 50 newtons. Now let's take two situations. In situation number 1, the box is lying on the surface in this position, and in situation number 2, the box is lying on the table, let's say in this particular position. First situation, when the box is lying on the table in this position, so we can say that the surface area of contact would be this much area. And in the second situation, we can say that the surface area of contact would be this much area. Now, in both these situations, the normal reaction would be 50 Newton, since the weight of both the boxes is the same, because these are the same boxes. But the difference is that the surface area of contact in this particular situation, in situation number 2, is more as compared to the surface area of contact in situation number 1. Do you think it will have any effect on friction? So we already know the reason of friction is the interlocking of the surface irregularities. So it will be only fair to assume that since in second situation or the second position, the surface area is more, so the interlocking would be more and hence the friction would be more. But is it really the case? Let's try to find out. So now let's try to understand how the surface area of contact affects friction with the help of this particular activity. Now here I have the same box but in two different positions, position number 1 and position number 2. Now as I am applying the force on this particular boxes, there would be some reading in the spring balance, and the reading would reflect the opposition forces. So the opposition forces in this case is the frictional force. Let's say I'm displacing both these boxes with the same amount, and I'm noting down what is the reading in the spring balance. So we will find out that the reading in the spring balance is same in both these situations. Let's say the reading in the weighing balance is 50 in this situation. It's also 50 in this situation. So the reading in the weighing balance is actually telling us about the frictional force, because the frictional force is the one that is opposing this motion. Now, as the reading in the spring balance is same in both these situations, it tells us that the surface area of contact has no effect on the frictional force. But this is sort of contrary to what we were thinking initially, right? We were thinking that in the second position, since the surface area of contact is more, the irregularities would be more, and hence the interlocking would be more, and hence the friction force should be more. But as we just saw, that friction is independent of the surface area of contact. So how do we explain that? So the reason behind that is, when the surface area increases, the pressure on each point decreases, because we know that pressure is equal to force per unit area. So as the surface area increases, the pressure decreases, and as the surface area decreases, the pressure increases. So what actually happens that these two effects cancel each other out, so the net friction force remains the same. And that is the reason that in this situation, even if the surface area was more, but the pressure was less, and that is why the friction was not increasing that much. And similarly, in this case, the surface area was less, but the pressure was more. So both the effects are counteracting each other in such a way that the friction force is not getting changed with the surface area of contact. So we can conclude that in ideal conditions, the surface area does not affect friction. So I hope you are now clear with what.
Right. So these are the three important factors which affects the surface area. So three factors clearly explained. One more is there, you can see.
Hey kids! In today's video, we'll be learning about friction. Are you ready? Let's begin! Have you ever wondered why your shoes make a squeaky sound when you walk or dance on a shiny floor?
Sound.
Or why is it easier to slide on a slippery slide than on a rough one? Well, today, we'll explore the answers to these questions and more as we talk about friction. So what is friction? Friction is the force that opposes the motion of objects when they rub against each other. It's like a hidden hand that tries to slow things down or stop them from moving altogether. Let's go over the types of friction.
That we'll see later.
Let's begin with static friction. This is the friction that keeps
Types of frictions we come across later.
rolling friction.
So these are other type of friction.
Finally, the type of materials in contact also matters. Some materials have more friction than others. Friction is all around us and serves many purposes. It helps us walk without slipping, stop our cars when we hit the brakes, and even hold a pencil while we write. Reducing friction. To reduce friction,
So
we can use lubricants like oil or grease to make surfaces slide more easily.
For reducing friction and all, we'll see in the next class. But before that, we are very much clear about what is friction and what are the factors influencing the friction. So friction is influenced by three factors. The first one is weight of the body, right? First one is weight of the body. Second one is nature of surfaces. What are the two surfaces we are considering? Either you and floor or heavyweight person. Suppose my weight is 70. So I am walking on the floor. The frictional force required for me is more than the person with the weight of less than me. And what kind of surface we are walking as for walking on smooth surface or oil surface or rough surface. Similarly, second one is weight of the body. Then second one is nature of surfaces. And third one is shape. Shape or area of contact does not affect the friction. Whatever the shape, whatever the area of contact between the two bodies, the frictional force purely depends only on the weight. That clearly in the video we have seen, right? Now, the next part is, before concluding, we left this. Friction, a necessary evil. Friction, very important point. Friction is not desirable due to following reason. When we rub our hands, they get warm. That too, especially winter season, we rub like this. This indicates that friction converts some part of energy into heat energy, which is dissipated into the atmosphere. This is the major disadvantage of the friction. Whenever you are rubbing two hands, what happening here? Heat is producing. Similarly, suppose in vehicles, when you are running the vehicle, either two-wheeler, four-wheeler continuously, because of the rubbing of each and every part, the parts will damage because of friction. For that, we have to go for some precautions. Every time we have to change the oil, we have to apply the grease. Even though it is very important, it will think like a evil only. Okay, this is the major disadvantage of the friction. A lot of energy get wasted in the form of heat energy due to friction. Due to friction, the energy consumption of machines is individually increases. Wear and tear of the parts, cracking and breaking of the machine increases, and span machines tend to reduce. lifespan of the machine reduced because of the continuous running. Why you need to change the vehicle time to time? Why you have to give for servicing? Because of the friction only. Friction increases the need for the fuel of the vehicles. More friction, it will give less mileage. Some vehicles give mileage of 30 kilometers, 40, some 100. Why? Because of the friction influence only. However, friction is also important too in our daily life concerning the following points. Not only the evil effect, not only disadvantage, because what he's saying is we are producing heat, but heat is wasting. Everywhere happens. Where there is a friction, heat will produce and we cannot use that friction. Means some energy is converted in the form of heat and we are losing that. It may be in the case of automobiles, that is car, vehicles, two-wheelers. Everywhere happens same only. Because of that only we are consuming the petrol. So greater the frictional force of the vehicle, greater the petrol consumption. Okay. But not only that evil effects, we have some importance also there, some advantages also there. See, first one, if an object started moving, it would be never stop if these forces no friction. If friction is not there, we cannot stop the any body. I told na, when you throw the ball on floor, we don't know where up to it will go. Still, it is obstructed by something. But force is very important. Had there been no friction between the tires of automobile and the road, they could not be started or stopped or returned to the changed direction of motion. If there is no friction, neither you can start the vehicle or a vehicle which is already started, you cannot stop the vehicle. No building could be constructed. So, because of the friction force only, building is standing near at one position. Friction can also produce heat. That is advantage also. You can use that heat. When you strike the matchstick against the rough surface, it catches the fire. So there also frictional force come into act. Because of frictional force only, we can able to produce the fire. Two bodies stick together due to friction. So writing is possible due to friction. If friction is not there, you cannot hold the pen. We cannot hold the pen without friction. We can able to hold the pen because of the frictional force only. Very important. It is having a whole lot of importance in our day-to-day life. Simultaneously, some evil effects also. But more of the advantages, right? So, this is about the friction. So, what is friction? What are the factors influencing friction? Why friction is real and how friction is useful. These four topics we discussed today. So, when you meet in next class, we'll discuss about what is the contact force, normal force. Just now we have seen a video also. And what are the types of frictions? There are three types of frictions are there. We'll discuss about all the three. And after that, what is some more about the method of reducing friction, increasing friction, and few topics are there. It may take one or two sessions, right? So that's all for today. Have a wonderful day. Thank you all of you. Thank you, Vani Block, Haran Reddy, Udi Malkapur, Arwal, ECIL, and Jogipet.